Hi everybody. Okay, so today is February 17th, and I want to just quickly remind you of the basic story in probability theory for this course. You have a population with members, a random variable named x taking values in the real numbers, and if you make a histogram with the possible values of x along this axis here, you can put above it the number of times a particular value of the random variable occurs, and you might get something like that. And in general, you get some kind of curve, and that curve is called the probability distribution of the random variable x. In binomial probability theory, we have a basic question about a random variable that takes exactly two values. So that means the members of the population, for example, the students in a classroom, might be exactly either male or female. We'll call that a binomial random variable. And then we encode the idea of male, let's say, with the number 0 and female with the number 1, because women are better than men. And you get a graph which takes on the possible values 0 or 1 a certain number of times. So you might have this story, and there are no other possibilities, so the sum of these two columns has to equal the size of the population. Now, the basic question in binomial probability theory is a little more elaborate than just one coin at a time, because what you can do is you can consider a sample of coins. A sample, let's say, of, 13 coins. And the basic question you can ask is, what is the probability of 5 heads in 13 tosses or flips of a P coin? A P coin is a coin whose probability of heads is between 0 and 1. So a fair coin would be P equals 0.5. Half the time it's heads, half the time it's tails. And in general, you could ask, what is the probability of K heads in N tosses of a P coin? So you have to assume, of course, that K is between 0 and N. 5 is between 0 and 13. And in that case, in general, you'll have a probability distribution histogram that goes from 0 to 1 to 2 heads and so forth, 5 heads, maybe up to 13 heads, where N is equal to 13. And this graph tends to look like this. This is just a review. I'm not doing the complete details on this, but I do want to remind you that there is a formula in algebra and a formula in Excel which calculate an answer to this question for arbitrary K, N, and P. So a notation that's frequently used for this probability, the binomial probability of K heads in N tosses of a P coin, is BNPK. And the algebra formula for that is N choose K times P to the K times 1 minus P to the N minus K. And we learned a little bit in class about how to calculate this in Excel using the factorial function, and it was kind of elaborate. because n choose k involves 3 factorials. You've got factorial of n divided by factorial of k times the factorial of n minus k, and that's very complicated. Let's just leave that alone for now. The main point of the review was to talk about point probabilities and cumulative probabilities. In point probabilities, we might ask the question about what is the height of this point in the curve, in the probability distribution. That's a point probability, and that was calculated with, well, first of all, that would be B13. Let's say we're talking about a fair coin at 5. And the Excel function for that is binom.dist at 5. N is 13, P is 0.5, and you put a 0 here for the point probability. So this point probability is that height. Alternatively, one has a more general question where you want to know what is the probability of being either 0 or 1 or 2 or 3 or 4 or 5 heads. And that's called a cumulative probability. And in algebra notation, that would be BNP 0 plus BNP of 1 plus BNP of 2 and so forth up to BNP of 5. Well, in Excel, that would be binom.dist of 5, 13 in this case, 0.5, with a 1 at the right end. So what that stands for is the cumulative probability in green. One of the interesting questions is, what is the probability of being more than 5 heads? 6 heads, 7 heads, 8 heads, up to 13 heads. In that case, you're talking about BNP from 6 up for a fair coin. And so you could add together a bunch of those. So I would start at 6 and then add BNP 7, 13, 0.5, 0, plus, etc. up to 13. And that's adding up a bunch of point probabilities. So that means I would be adding up like this, plus this, plus this, plus this. But in Excel, the binom.dist function only calculates left tail cumulative probabilities. Left tail means from a certain point going to the left, and that's a left tail cumulative probability. So that's a little bit of a problem if you wanted to do this red part here. If you want to calculate this red part, the right tail cumulative probability, you can use the left tail probability because you know that the sum of all the probabilities is equal to 1. So the red part could be calculated with 1 minus the left tail cumulative probability. Let's say at 5 and 0.5. And so you see I'm putting a 1 here to get that cumulative probability going from 5 to the left. But by subtracting from 1, I'm getting this red part. And so we have the general rule, of course, that green plus red equals 1. That's basic probability theory. Now, you don't see that, so let's make sure you see that. Okay?